Okay, no one's really speaking up. So for question A, what we're trying to get, or test, and I should say I didn't come up, is we're trying to connect the idea that the slope of the tangent line is somehow related to the derivative. Does that make sense? This goes all the way back to chapter 2. This isn't even chapter 5 stuff. This is going all the way back to like September of last year. The slope of the tangent line is equal to the derivative. Well, what did they give us? The derivative. That's what dy dx is. That's what a differential equation in this case is. It is the derivative. So we're going to have to write the equation of a tangent line, which might look something like this. You hopefully are familiar with this notation. That's called point slope form. We know what y1 is. Well, y1 is 0. We know what x1 is. x1 is 1. So the thing we've got to do is figure out what the slope of the tangent line is. Well, that has to do with the derivative. In other words, you need to plug in 1 for x and 0 for y. So let's go ahead and look at the scoring for this particular problem. It is out of 3 points. 3 points for this. Point number 1, does the student use the derivative at 1, 0 to find the slope of the tangent line? Well, let's see here. If you put 0 in for y and 1 in for x, you'll get -3. The derivative, that's what that means, is -3. Therefore, the slope of the tangent line is -3. The second point is to write the equation of the tangent line, which, by the way, is the same thing as this. You do not have to write y minus 0, but I just want to emphasize that y is 0 and x1 is 1. The slope of the tangent line is -3. So this tangent line gives us, as long as we're close to 1, a very good approximation for the value of the function. By the way, do we know yet what y is? Do we know what y equals f of x is yet? Nope, we don't even know. However, we can use this equation to approximate the value of the function there. So what you're going to do is plug in 1.2 into our tangent line equation, and you will get -0.6. -0.6. So 1 point to find the -3, 1 point to write the equation of the tangent line, and 1 point to get the -0.6. Do you guys feel like that's a fair question to ask calculus student? I think so. I think so. I think this is very fair. Did you get it? Did you all get it right? I bet you didn't all get it right. But now that you've seen it, hopefully you can say, okay, that kind of makes sense. Now I have a question for you. Did anyone try doing the derivative of this thing up here? Now, if you did, that means you're trying to do the derivative of the derivative, which would be the second derivative. And this question is not asking us about concavity. It's asking about us the slope of the tangent line. So we already got that. That's the formula for the equation of the tangent line. I'm sorry, the slope of the tangent line. Okay, so let's go back to question 2, or question B, I should say. It says, find the particular solution. So what is the big idea of this question? Question A was connecting the idea of the slope of the tangent line equaling the derivative. What about question B? What's the big idea? Don't all answer at once. Okay, good. Someone answered. I was going to say, if you don't answer here soon, someone raise their hand, I guess. Gabe, go ahead, Gabe.
Is it using the integral?
Absolutely, sir. Very good. Gabe, you just saved your classmates from having to see my mustache again. I was about ready to pull it off. I don't want to scare you guys. So question A, we're trying to connect that the slope of the tangent line is equated with the derivative. Now in question B, maybe I'll do this in a different color. In B, we're going to use integration to undo, if you will, undo the derivative. And that's what we do. That's what we've been doing all of chapter 5. We've been using integration to undo the differentiation. In other words, we've got the derivative. How do we get back to the original function? Well, we're going to use integration to do that. So let's go ahead and I'm just going to go right to the scoring on this one. I'm going to tell you right now, this is out of 6 points. Remember, 9 points total, 3 from the first part, 6 points for this second part. This particular free response question only had 2 questions, which is actually unusual. Usually it's 3 or 4. So let's go through how to get those 6 points. Before we begin, I would like to note, how many points do you get if you did not do separation of variables? 0. So if you did not, somewhere on your paper, have all the y stuff on the left and all the x stuff on the right, or vice versa, but usually we put the y stuff on the left, then you can quit scoring. You got a 0. Okay, so this is the most important step. So your first point is separation of variables. The next 2 points are for the antiderivatives. On the left-hand side of the equation, the antiderivative will be negative e to the negative y. I think this is the hardest one for students to get. The one on the right, I think that everybody should be able to integrate 3x squared minus 6x. You will get x to the third. I'm sorry, yes, I said that correctly. X to the third minus 3x squared. So there's 2 points there. So a point here, a point there. You get the 4th point for putting plus c. Now I want to ask you a question, and you don't have to answer it. This is just a question for you to think about here. Were those really 4 hard points? I would say those are pretty simple. Now you might say, Mr. Allen, I screwed up on the negative e to the negative y. That's okay. But did you get the x to the third minus 3x squared and the plus c? Did you separate the variable? You got 3. That's really good. The next point, the 5th point, use the initial condition. In other words, plug in the 1, 0 to figure out what c is. There's 5 of the 6 points. The last point is the hardest point. This one is the most difficult. And it has nothing to do with calculus, unfortunately. And it is simply getting all of this stuff to y by itself on the left and then everything else on the right. So if you got that one, you need to pat yourself on the back because that's tough. Y equals negative natural log absolute value of negative x cubed plus 3x squared minus 1. That's your answer. Okay, so if you take however many points you got on part A and however many points you got on part B and add those together, that'd be your score. Okay. So this is a free response question. I can't remember which year this was an actual problem on the AP exam. This isn't something that Mr. Allen made up. I literally got it off of the College Board website. So this problem here, there's 6 points for the stuff we've just been working on. So that I'm trying to emphasize, some of these things are tough. Don't get me wrong. This is not an easy test, but you should be able to get some points on these problems. I think you should be able to get several points, but we need to expose you as much as we can to these types of problems so that you're not looking at them and going, wow, I don't even know where to begin. There's a lot of words and things like that. Anyways, comments or questions on this warm-up? And I know it's kind of a longer warm-up, but I'm trying to give you guys a chance to experience some of this stuff. Yes, David?
Can you go over how to integrate dy over e to the y?
Sure. Okay, so the question is, how do we integrate dy over e to the y? Okay, so I would say this. And I'm going to show all my work here just to make sure. So hopefully you guys recognize that. Now I'm going to go one step further, and I'm going to say that, well, that's the integral of e to the negative y dy. Notice I haven't done any integration yet. Now I'm going to use my favorite integration method, u sub. And my u substitution, I'm going to let u equal negative y. Du would be equal to negative dy. But there's no negative in that integral, so I'm going to go ahead and move that negative to the other side. And now I can convert this integral. This right here will now become negative integral 1 over u. Actually, I'm sorry, I did that incorrectly. It should be u to the negative 1. U to the negative 1 du. Oh, I wrote it wrong again. Guys, I am making some major mistakes here. I apologize. It'd be e to the u. There we go. I will third time's the charm. So I had the integral of dy over e to the y. Then I just wrote that as 1 over e to the y. You can think about it that way. And then, well, that could just be e to the negative y. So now we're here, and the integral of e to the u is just e to the u. But what's u? Negative y. Remember, on the problem we did over there, we didn't do the plus c because that was on the left-hand side of the equation. Did that help, Dave?
Yeah.
Okay. Sorry about that mistake. Any other questions on the warm-up thingy here, these differential equations? One of the nice things about this unit, this chapter on differential equations, is number one, it shows you the application of all the stuff we've been doing, but also it's a very good review of all the stuff that we needed to learn earlier in the year. Okay, so I'm going to go ahead and go to bullet point number 2, if that's okay with you guys. Bullet point number 2, AP exam. So let's talk about this here real quick. Tuesday, May 4th, 8 a.m. And it's at PMHS. There is no virtual option. Let me make sure I say that again very clearly. You do not get to take this test online. There is no virtual option. You have to do paper and pencil. Okay? There's only paper and pencil, which means it will be in person. Guess what that means? Guess what you will not be allowed to use? Notes. You will not be allowed to use any notes on this test. I hope you're understanding what I'm saying, because every assessment that we've taken this year in this class has been an online thing. Because most of you, like right now, I have, right here, I'll just show you. Here's my class. Hi. I have one student in here. Okay, a couple of other things about the day. We met last Wednesday with all the AP teachers, and we discussed when we were going to take the tests. And just let me give you some history. For example, in the past, students that took the AP calculus class in the morning, guess what they took in the afternoon? If you were taking physics, you took AP calculus in the morning for 3+ hours. You'd go eat lunch, and then you would take AP physics 3+ hours in the afternoon. That is a rough day, if you ask me. Very rough day. So here's how it's going to happen. So specifically, AP Lit and AP Physics and Calculus, those are the ones that we were worried about running back to back. So if some of us did it later in the month, because we had 2 windows, we could do this. And I think the other option was, in fact, let me see if I can remember. Who's had AP Physics, or has AP Physics in here? You know what the date is for theirs? Is it May 20, gosh, I saw this, 24, 25, something like that, 24, anyway, whatever the day is. The physics students are gonna have theirs on May 24th. That way, if you're taking mine, you'll take it on May 4th. You will not have to take an AP Physics that afternoon. Now, the AP Lit is on Wednesday, the 5th. Actually, I think it was that one was going to back up against the physics. If I had moved mine to the later day, then it would have backed up with the AP Physics. So we were trying to avoid having you guys have to do 2 AP exams on the same day. I hope that makes sense. So the AP Calculus one is on Tuesday the 4th. The AP Lit is on the 5th. There won't be an exam in the afternoon of either of those days. And then the AP Physics one is, I believe, the 24th, or whatever day Mr. Siebold will tell you, or whoever else might be teaching it. Does that make sense? But I need you just please hear me. This is in person. You are going to have stuff in your head. This year, we've only been meeting as a class twice a week. That's not very much. Every year up till now, we've met 4 days a week. In fact, if you have friends that went to a different school, like in Franklin or something like that, they've probably been going 4 or 5 days all year long. So we are behind the curve a little bit. In fact, 2 years ago, guess what happened the week after spring break? What did I do as a teacher? I was in complete review mode for the AP exam. I would spend a whole month reviewing. We're not done yet. We have this week, and then the weeks we come back, I've got like 3 more sections of material I need to cover before we take the AP exam. So there's not going to be as much review time. So you guys are kind of behind the 8 ball on this. Now, I'm not saying that to be discouraging. I'm just telling you the reality of things. We've only covered, in general, 1 section of material a week. Very slow pace for calculus, okay? And that's just the way it is. So now I want to talk a little bit about the mock, which I'll talk about the format as well. I'm going to go back here, hopefully, there we go. So this is in our, thinking back here, I'll scroll up here a little bit. So you can see this week, I don't have a lot of things on the Canvas page. I've got a video here from the AP Central people. It's a long video, but it's a review of differential equations. I would encourage you to watch it. Last week, I put the differential equation review and the answers here. And then I've even got an extra set of problems on the Canvas page if you would like to look at those. I've got those if you want extra problems. And then, of course, we'll have our test tomorrow. Okay, so back to the mock. Guys, I see you twice a week. We can't just say we're going to spend today doing a mock exam. If you look at the amount of time, so there's 90 minutes plus 50, so that'd be 140 plus, so we're talking 200 minutes of test. Okay, it's going on 3 hours of just testing. That's if you did no breaks. That is a long calculus test. We do not have time to do that in class. We're still under restrictions in terms of mass and things like that. So what I did, and I mentioned this last week, is I have posted this Canvas module on what I call a mock exam. And I've given you directions. Here's how the actual AP exam will be on May 4th. The first section will be multiple choice without a calculator. 28 questions, 55 minutes. No calculator. The second AP test for this class will be multiple choice again. This time, calculator will be allowed, but this time there's only 17 questions, and you get another 50 minutes. You might say, wow, Mr. Under, you're getting like almost half the questions, but about the same time. Because remember, when we're working with these calculators, it takes time to like do stuff, even on the calculator. Even though it seems like the calculator stuff should be faster, in my experience, students take more time on calculators than no calculator. Test 3 will be free response, calculator allowed. 2 questions, 30 minutes. So basically, if there's no calculator, then whoever's proctoring the test will say, okay, guys, now you can use your calculator for parts 2 and part 3. And then after part 3, you got to put the calculator away. And then you're going to have to deal with 4 more no calculator free response questions. So that means there's a total of 6 free response questions on the AP exam. And I'll just tell you right now, there won't be repeats on questions. There'll be a question on this topic, a question on this topic. So just like the one we did in the warm-up today was kind of specifically on differential equations, that's how they'll be, okay? Then, by the way, all of this is available for you right now. I made it open up last Wednesday. And I don't want anyone to raise their hand. You know what would be awesome is if someone out there has already started and done 1 or 2 of these parts of this test. Kind of getting ahead of the curve. That'd be great. Okay? You might say, Mr. Allen, last week was a rough week. I didn't. That's fine. I'm not telling you you're a bad person for not doing it. Not at all. Between now and right after spring break, though, I would encourage you to do this. Now, it's not for a grade. I'm not going to come, knocking on Nathan's door and say, Nathan, did you do the mock exam? If Nathan chooses not to do it, that's on Nathan. I will tell Nathan this, though. He will, if he's really wanting to try to have a good shot at doing well on the AP exam, you're going to want to try to do some of this stuff in advance so that you know what you're facing. That's why I'm doing the warm-ups. Here is the scoring rubrics. So you can score your own test. You don't have to tell anybody. So you can go and figure out what all the, and that's going to release on the last Friday of spring break. I think it's April, I think it's April 2nd that's going to release. I believe that's right. And so then you can score it, and you might say, Mr. Allen, I'm going to Florida, that's fine. But that will be released. And then the last part there is the scoring worksheet. So you can actually score, I got this many on the free response, correct? I got this many on the multiple choice, and it'll show you how to put those numbers together to figure out if you get a 1, 2, 3, 4, or a 5. Whatever you get, like let's say you get a 2 on the mock. If you get a 2 on the mock, guess what you should expect to get on the AP exam? I would say at least a 3. Okay? Because first of all, there's some stuff I haven't covered yet, and you're going to probably not do well on those. So you're going to do better on the real thing than you will the mock. But if you don't do the mock, your first try, just think about anything you do, the first try, you usually don't do as well, right? I guess you probably think of some exception. But in general, you get better with practice. So let's say you get a 2 on the mock, then you should be like, okay, I'm going to get a 3. If you get a 1 on the mock, please don't feel discouraged. It's going to be hard. It's your first time taking it, and there's some stuff I still haven't covered yet. If you get a 1, that's okay. By the way, you cannot get lower than a 1. Okay? If you get a 3 or a 4 or 5 on the mock, you should be feeling super good about yourself because you're going to crush the exam. Okay? Does anyone have any questions about the mock? And again, guys, I'm putting that on you. I gave it to you last week, and I'm just, if you can get it done before we get back from spring break, that'd be awesome. If you want to wait till the Monday we come back from spring break and then do it that week, that's fine too. But that week we come back from spring break, I have to cover some new material. We're going to cover section 6.1. Okay? All right. So we have talked about the warm-up. We have talked about the AP exam. Now we're going to go to chapter 5 review. Okay, so hopefully this will go better than it did earlier today. My third period class, I tried to do this with them and I screwed up the permissions or whatever. Can you guys open that Jamboard? I sent you a Jamboard in the chat. Hopefully you have permission. That's the thing I screwed up last period is I did not have the permissions set right, and they could open it, but they couldn't type anything in. So when you open up the Jamboard, there's some directions there at the top. Can anyone confirm is that available? Be able to get into that Jamboard? Okay,
yes, you're good, Mr. Allen.
Awesome, thank you, Logan. So at the top, there's three options. I need you to do one thing. So what I would do is get one of those sticky notes on the side, and you do not have to put your name on it. If you're bashful, that's fine. Do one of those three things. I think one of them is, what question do you have on the Chapter 5 review? Or another one is, which question do you find the most difficult on the review? And then the third option is, and again, you don't have to put your name, explain to me why you didn't do the review. Okay? I'll give you a minute to do that. I'll pull it up here in just a second. All right, guys, sorry, I didn't mean to grab the stuff there. Hopefully you guys can see this. I'm just trying to get some feedback so that I use your time wisely. I mean, I try to do the 60-30 thing. I try to honor your time. So I just was hoping this might help us. We don't have time to go over every possible thing, right? But I'm hoping that I can hit kind of the main questions that people are. So let's see your question 8. 7, question 10. I see a couple on question 10. 3, trapezoidal rule, and 8. And I think part C is the trapezoidal rule part on that one. I think.
Yep.
So I think questions 8 and 10 we need to look at. Question 5. Yeah, question 5 is a pretty hard differential equation, I think. So if you struggle with that one, I get it. I think that was the hardest differential equation one, question 9. Okay. So I think I'm going to start with question 8, if that's okay. If you guys want to keep adding stuff up here, that's fine. Thank you so much for doing that. This is going to hopefully streamline our discussion here. So, guys, I'm going to write an answer down on parts A, and then I'll talk a little bit about B. But please stop me if you're like, Mr. I don't understand how you did that part or whatever. Also, please keep in mind that this problem at the very top, it says calculator. So if you're not using a calculator to do these problems, you're probably making it more difficult than it needs to be. So for question A, we know that it triples every 4 years. So I would just say 4 equals e to the 4k. Oh, triple, so that'd be 3, sorry. It should be a 3. That should be a 3. So in other words, the ln of 3 and then 1/4, that's what k is. So there's your k value. All right, and just to let you know, the k value there as a decimal, in case you did a decimal, which is fine, is 0.274653, and there's some more digits. I would store this, oops, there we go. I would store this in my calculator. I would store that decimal in my calculator. That way I don't have to keep typing it. If you need to know how to do something on your calculator, today is a great day to ask, okay? Also, we know that in this case, that in the problem, the initial amount was given, is 8 million. In other words, this whole thing is PT 8E to the 0.274653 T. This is the equation that you need to write for this. Okay? And I guess I should have said that too. C is 8. So here's K, and then here's C. And we put both of those things to get the general model. So here's what I'm trying to tell you. What does this equation mean? This equation here is telling us how many Pringles are produced, or as produced or consumed. Yep, consumed in a given year. So I wanted to know how many Pringles were consumed in the year 1999 based on this model. Guess what I would plug in for T? 9. You just plug in 9, type it in your calculator, hit enter, and it'll tell you how many Pringles were consumed that year. Does that make sense? So there's part A. Okay, part B. Now this one's kind of a tricky question because of the word average. And it even says average rate, which might make some of you think, oh, I need to do the slope formula. That is not correct. This is asking us, what is the average value of the consumption function? Write it like that. What is the average value of the consumption function? This is this is how much is being consumed in a given year. So we need to use our average value formula. And you might say, well, Mr. Allen, it says rate. Guess what this equation is? It's the rate at how much is consumed. So this is the rate. So this is not a slope question. This is this formula right here. And I'll let you know that this comes from section 4.4, which is probably the most important section in the book, in my opinion. And so we're going to integrate from A to B of our function t dt. This is how you will find the answer for this problem. Now it says 13-year period starting January 1st of 92. In other words, A is 2 and B is 15. Now, where did the 15 come from? Well, guess what's 13 years after 92? 2005. In other words, 15 in the context of this particular problem. So this is what we're going to do. So this is going to be the integral. Oops, don't forget the beginning part. So that's going to be 13 from 2 to 15 of our function. And this is all I would write. And now let's practice with our calculators. Please don't just pretend like you're doing this. Would you actually do it? I've done all the work for you. Here's our function, right here in blue. Integrate with this formula. Don't forget the 1/13 in the front. See what decimal you get when you plug it in your calculator. Let's make sure you know how to use your calculator to do integration. But my hope is that you actually use your calculator now to actually practice this. You should get 134.020. And that's millions of cans of Pringles per year over that 15-year period. On average, about 134 million cans of Pringles are consumed each year. That's the answer to part B. Does anybody have any questions on how I got that answer or how to use their calculator? Today is a great day to ask questions.
Yeah, can you show how to put it in your calculator? Because when I put it in there the same way you did, I got 8.5.
Okay, so here's what you want to do. In fact, let me see if I can pull this up on my calculator on the screen. Whoops, wrong one. Sorry. There we go. Okay, so let me clear this. All right, so now I've got to do a little bit. I'm going to show you guys. I'm sitting at my computer, so you guys kind of have to just stop me if I do something and you're not sure how I got it. I'm going to do the ln of 3 divided by 4, because that was that constant we needed to get for this problem. Now I'm going to store that by hitting the STO button, and I'll go ahead and store it in K. All right, so there's K. So now I can plug everything in I want to do problem B. So to do problem B, I would do 1 divided by 13 in parentheses. Then I'm going to go to math, option 9. I'm going to integrate from 2 to 15. And then I'm going to put 8 e to the k x and then dx. Now I'm not going to hit enter yet, but look carefully at what I just did there. Does that make sense? Can you see? I mean, I'm literally, this is the nice thing about these calculators, is it looks almost identical to what we were doing right there on the problem. This out of the way. So this is it. So I got the 1 over 13 integral from 2 to 15, and then here's 8 e to the kx. The k is this 0.27, blah, 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 and then I'm just going to hit enter. Does that help? Okay. Any other questions on part B? Okay, let's look down at part C, because this is the thing that most people asked about here. I'll go ahead and leave my calculator there. So for part B, they want us to use this thing called the trapezoidal rule. Okay? So I'm going to explain to you where the trapezoidal rule comes from, because I think it's a hard formula to memorize. In fact, I don't memorize the formula. I just think about trapezoidal rule, and the shape is trapezoid. So I'm just going to give you my thoughts on how to get it before I do it. So let's say that we've got some function here, and this is a different problem, but let's say it does whatever it does, and I want to find from, let's say, 1, 2, 3. Let's keep it simple. Let's go to 4. Okay, and I want to estimate. Oops. I want to estimate the area under that curve from 1 to 4. Okay? So one way I could do it, and you'll probably remember this from the past, is I could use left Riemann sums. I could do something like this, and there'd be 3 rectangles, And I would just figure out, let's just say that, you know, just to keep this super simple, let's say that this is 5, and let's say that that's 6, just to keep it super simple. All right, so what I would do here for left-hand Riemann sums, I would do, okay, so you've got to do the left side measure times the width of the rectangle. So that's going to be 5 times 1 plus the next rectangle. Well, the left side measure is 6 times 1. And then that last rectangle happens to be, and I'm just making this super easy on myself, is this, and I can then add those all together, and it looks like I get the area is roughly 16. Does that make sense? Now that's a left Riemann sum, and those are super easy. You just basically look at the value of the function, and then in this case, each of the rectangles has a width of 1. So that's very simple. In fact, you could have even done this more simply and just said it's 1 times 5 plus 6 plus 5, which is also 16, because all those ones can be pulled out using the mixture. So that's left Riemann sums. But this question says, no, we're doing trapezoids. So now we do the same problem, but with trapezoids, okay? All right, I'm going to do it in purple. Let's do lavender. Lavender will be pretty. Okay. So now we do the same problem, but now I'm going to do trapezoids. You know, I may say, Mr. this is a trapezoidal rule. Yes, it is. It's just trapezoidal rule is just saying here's a fancy formula for it. So now, instead of these rectangles, what I'm going to do is I'm going to draw trapezoids, and they're going to look like this. So here's my first trapezoid. Here's my second trapezoid. And then here's my third trapezoid. By the way, you'll notice my third trapezoid is really just a rectangle. But we're going to call it a trapezoid thing, okay? So how do we find the area of a trapezoid? Well, the area of a trapezoid is 1/2 the height times base 1 plus base 2. This goes all the way back to middle school. That's the formula for the area of a trapezoid. Now, don't forget that the bases are the parallel sides. The height is the distance between the two parallel sides. So let's look at trapezoid 1. So for trapezoid 1, I've got to do 1/2. Now, what's the height between the two bases? Well, it's 1. Now, what's base 1's length? Well, it's 5. What's base 2's length? 6. And I'm just looking up here on the y. And again, I made a super easy problem for myself. Okay, so that was for the first trapezoid. Now I'm going to do a slightly different color in purple for the next one. So this one's going to be 2. Okay? Now we got another trapezoid. So I'm going to do 1/2. The distance between them again is 1. And then the first side there, that distance turns out to be 6. Oops. 6. And then that second distance turns out to be 5 again. So there's the area of the second trapezoid. And then the third trapezoid, I'll pick one more color of purple. Let's do this guy here. Is going to be the same thing. So it's going to be 1/2 times 1 times, and in this case it's 5 plus 5, I think. Because that distance is going to be, this distance is 5, and then this distance is also 5. Now, what do you notice that all three of those things have in common? Well, they all have 1/2 times 1, don't they? So I'm going to go ahead and I'm going to do a little bit of algebra here. So I could rewrite this as 1/2 times 1. And then, now here's what I would like you to notice. And I didn't pick a great example here because I used 5 multiple times. But you see this first distance here, this first vertical distance? That's at x equals 1. How many times do I need that distance? I only need it 1 time because it's only this one base. So that's going to be, let me write it in this purple here. This is going to be 1. and then that distance is 5. Now let's look at the second one. This distance here for x equals 2, which is 6, right? Well, you'll notice that that's the left side of, or the right side of trapezoid 1, but it's the left side of trapezoid 2. In other words, what I'm trying to tell you is this. Do you see how that 6 is the last one in this one, but the first one in the second one? So we used it twice, so that's going to be 2 times 6. Okay, what about this one here? Well, that's the right side of trapezoid 2, but it's the left side of trapezoid 3. In other words, what I'm trying to say is this guy and this guy happens twice. So that's going to be 2 times 5. And then this last guy here, that is only used once, so that's 1 times 5. Now, what I'm going to do before I get my final answer here is I'm going to write the formula, which, by the way, is in section 4.3, in case you're like, Mr. Allen, I don't understand what that you're saying. And here's the formula. B minus A over 2 times N, quantity F of the first one, plus 2 times F of the second one, plus 2 times F of the next one, blah, 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 plus, and then F of X of N times 1 time. Here is the formula, and you might think, Mr. Allen, that does not, I don't see the connection between these two. Remember when I said we had to multiply this one? Remember when I said we had to multiply this 6 twice? That's why there's that 2 there. Remember I said we had to do this one twice? That's why there's 2 there. But the first one and the last one, that's why there's no 2 there. Okay? Also, this 1/2 comes from this right here. There's 1 over 2, that's the 1/2. This 1, that's because the distance between each of these particular ones that I did, well, it's just 1. So this right here, this B minus A over N, in our case, in this particular problem, we're going from 2 to 9, which is how many? I think that's 7, isn't it? So in our case, that's going to be 9 minus 2 over, and then how many trapezoids are we doing here? I think that would be 6. There'd be 6 of them. Let me make sure I don't tell you all of that. Where is it? You see where it's with my answers. Oh, here they are. They're over there. Oh, it's 8. I think I typed that wrong. I think this was supposed to be 8. Do you guys have that on yours?
For B?
Yes, for C. Is it 2 to 8 or 2 to 9? Can you guys check?
Well, it's 2 to 8 on C, but that's B.
Oh, okay, gotcha. I'm sorry. Yeah, thank you. I was just like, did I do something wrong here? This was 8. Anyways, 8 minus 2 is 6, and 6, and so that's going to be 1. That's why this was 1. Anyways, all the work on that one comes from this formula right here. So let's just go ahead and work this out. Now, to get this with your calculator, guess what you have to have plugged into your calculator? Where's it at? Oh, there it is. It's all the way up there. So if you have not done so yet, would you please, with your calculator, in Y1, go here, and hit clear, and now I'm going to plug in this equation, 8 e to the k x. There's my equation. And I need my window to go from at least 0 to, it was 2 to 8, but I'm going to go from 0 to 10, let's say. And I don't know, I'm not sure what my y min and my y max needs to be, so I'm just going to do, I don't know, 50. Let's see what happens here when I graph this. Okay, that actually was pretty good. Looks like I need to bump it up just a little bit more here. Instead of going from 0 to 50, let's go up to 100. Let's see if that works. Perfect. Okay. So we've got our graph for this function plugged in here. 8e to the kx. I've got my window set from 0 to 10. The min for y is -5. The max is 100. Okay, so now let's get down to it. I spent a lot of time working this out. I'm going to erase this Riemann sum stuff here so that I can start writing this in here. Okay? So for this particular problem, we need to do the following. We're going to do b minus a over 2n integral from a to b of, actually, I don't need that. We're not doing the integral, we're just doing the trapezoid over here. So we're going to do p of, the first one was 2, right? Plus 2 times p of, the next one would be 3, plus 2 times p of, and I just wrote an extra set of parentheses I didn't need there. Plus 2 times p of 5, plus 2 times p of 6, plus 2 times p of 7, plus, and then just p of 8 by itself. This is what you've got to do. It's just trapezoids is what we're doing. So we are going to plug in 8 for B, 2 for A, and 6 for N, if I'm not mistaken. And so that's going to give you 8 minus 2 over 2 times 6, which I think is 1/2. And then I've got to do, all right, so how do I find P2? Well, I go to my calculator. Here's my graph. I could literally just go calculate value 2, enter. It's right there. It's 13.856406. That's how I find P2. The other thing that I could do is I could just go to table and go up to number 2 and go over here and it will tell me 13.856406, blah, blah, blah. That's how you do it. You don't have to do that in your head. You just use your calculator. And so you're going to get 1/2 times 13.85641 plus 2 times 18.23, and I just use my calculator to find that one, plus, and then you just keep going down the line. Now, before I wrap that particular part of that question up, this trapezoidal rule, you know how I said I had to kind of cut some things out? That was the one thing I did not present in class. I did it in my video. Did you watch my video? All the way back in section 4.3? I have a feeling some of you maybe did not. Okay. And by the way, just by watching the video doesn't mean you understand. That doesn't mean you understand. You still got to practice. It's not hard. This is not hard. It does take some practice, and it does take some understanding of how to use technology. Okay, so that's question C, and I think I'm going to stop on question 8 there because we're I think we're past our 60 minutes now, aren't we? If we are. So guys, if you want to cut out of here now, you can. Does anybody want the extra problems? I put the extra problems. Does anybody need a copy of those? Yeah, and I've got a copy here. If you want a copy of those, I can do that. I'm going to go over question 10 now next, because there are several people that asked it. But if you don't want to stick around to see how to do question 10, that's fine with me. Okay, so here's question 10. Question 10, this one is again very similar to the one we just did. It says the rate of change of the amount of deer is directly proportional to the amount present. The Wild Game Commission estimates that 495 deer are in a particular state park. It wants to reduce overcrowding. So 10% of the deer will be removed from the pack each year. Let PFT represent the number of deer in the park at that time. At time T equals T, which is in years. And let K be the constant of proportionality. So guys, hopefully you know that if we're talking about it, a proportional relationship, that's going to be our solution, right? Honestly, if you've learned nothing from this chapter, if you don't know that, then we got trouble. Okay, that is the general solution for any exponential growth or any exponential decay problem. Now, in this particular case, they're telling us that the deer are getting out of control, so they're going to try to actually remove 10%. It's kind of cruel. They're basically saying we're going to eliminate 10% of the deer each year. So let's kind of put that into practice. So if there were 400, in fact, here, let's just keep it simple. Let's make it even easier than this. Let's say that there are 1,000 deer at some given time. What would be, if I removed 10% of the deer, how many deer would there be?
900.
It'd be 900, right? 10% of 1,000 is 100, so this would be 900. And that would be how many years? How many years would it take for that 1,000 to go to 900? Well, it'd be 1. So they are literally telling us, and again, it's kind of a weird example, that each year, instead of letting the deer grow, they're going to remove 10% of the deer. So now we can divide, and that's going to give us 0.90 equals e to the k. So k in this problem is simply going to be the natural log of 0.9. That's what k is. And just to let you know what k is in that case, in terms of a decimal, that is approximately negative 105360517. That's what k is. In other words, our model is going to be P of t equals 495 e to the negative 0.1054 t. That's our model. Now, guys, I rounded to 4 decimal places. It doesn't really matter too much in this example, but so now we can use that to find this answer. Just let t equal 5, and that answer turns out to be about 292 deer. So after 5 years of reducing the population by 10% each time, you're going to be down to roughly 292. Okay, so question C. Now things change a little bit here. It says after this 5-year period, no human intervention is going to take place anymore. In other words, they're not going to start, we're not going to, I mean, this sounds bad, but it's true. We're not going to eliminate 10% of the deer anymore. We're going to let them grow. We're going to let them repopulate. And it says the deer population increases at a rate directly proportional to this. In other words, now we've got a new differential equation here. This is going to be dP over dt is going to equal k times, and then that's 650 minus p. That's our differential equation for directly proportional. So we're going to separate our variables. So we're going to say that dP over 650 minus p is equal to k dt. I have separated my variables. Now I can integrate. And then once I integrate, now guys, I'm going to tell you on the right-hand side is easy, right? That's just going to be k t plus c, right? That's an easy one. But on the left-hand side, that's where you have to use that natural log with the u substitution. And that's going to give you negative natural log absolute value of 650 minus p. Now, it probably feels a little bit like deja vu right now, because it is. I've done this example, not this exact one, but something very similar to it twice in class. I did it on the day that we did the notes. Actually, I did it 3 times because I did it on the video that I posted on Canvas. I did it the day I did the notes in class, and we also looked at it when we did the activity in class. So you've already been exposed to this question 3 times. Now I just need to solve this out, and so I'm going to get rid of the negative. So it's going to be negative kt plus c. And then I'm going to exponentiate both sides. We're exponentiating the left side, we're exponentiating the right side. And that's going to give me, not natural log, that's going to give me the absolute value of 650 minus p equals c e to the negative kt. Anyways, this will turn out to be p equals 650 minus c e to the negative kt. And by the way, if you want to make, it doesn't really matter if this c is plus or minus. You'll figure out what that is once you do the work on with the initial condition. So this is the general solution. And then to find the particular solution, you use the answer from the previous problem, and now we're just going to restart the time at 0. And that'll give you what C is, so that you end up with the following once you figure out what C is. It's 650 minus 358, and then e to the negative kt, I think. Yeah. So there's your answer for that one. So what you would do is you would, so up here, you're going to put 0 in for t. So this is just C now, right? So you're going to get, over here, you're going to get 292 equals 650 plus C, and then so you're subtracting. Yeah. Does that make sense? And then for part D, they're telling you to find K, what they're asking you to do. So they're saying year one, 350. So in other words, you're going to plug 350 into this equation. In other words, you're going to get 350 equals 650 minus 358 e to the negative K. You solve that for K. K turns out to be negative natural log of 150 over 179, or 0.1768 approximately. And then you can use that to find the limit of the last one, which is the carrying capacity, right? That's going to be 650. Okay, so there's 10. Oh, I think I've been on mute that whole time. Guys, can you not hear a word I just said? Okay. All right, what other questions you guys got? We're getting close to being done here.